Hi everyone, welcome to Module 10. If your career path is in IT, you won't just be building and or maintaining networks. You are also responsible for the security of your network. With the kind of world we live in today, security is not an afterthought. All the modern network architects and administrators make security a top priority. In fact, today many people in IT now work exclusively in the area of network security. Several questions arise while working in the security domain. Do you understand what makes a LAN secure? Do you know what threat actors can do to break network security? Do you know what you can do to stop them? This module is your introduction to the world of network security. So, why wait? Let's get going into this. So, in this module, what we are going to cover here is we are going to talk about endpoint security to mitigate attacks, and we are also going to talk about how AAA and 802.1x are used to authenticate LAN endpoints and devices. And then we are going to talk about the layer 2 vulnerabilities, how a MAC address table attack can compromise LAN security, and what are the other types of LAN attacks which compromises the LAN security. These are all the things that we are going to talk about in this particular module. So let us first start with endpoint security. What do you mean by endpoint security? First, before I even talk about endpoint security, what do you mean by an endpoint? In layman terms, endpoints are nothing but the devices that are used by the users. So every day in the newspaper or on the news, if you see, you will come across some kind of network attacks. So if you want to know what is the current trend that's going on, just simply type in the latest network attack on Google and see what you get. You will be definitely getting many links which point out to the latest attacks that are happening in the world. Most likely, these attacks will involve one or more of the following. The first one being the distributed denial of service attack, DDoS attack. This is a coordinated attack from many devices called zombies, with the intention of degrading or halting the public access to an organization's website and resources. The main aim is to disrupt. That means even an authorized user will not be able to access the resources. That comes under the distributed denial of service attacks. We call them as zombies, and we also have bots or botnet attached to these things. The second type is called as a data breach. This is an attack in which an organization's data servers or hosts are compromised to steal confidential information. Imagine if all the credit card information has been leaked from a particular bank. That comes under data breach. The third one is being the malware. Here, in this kind of attack, usually what happens is this targets the hosts in an organization network. The hosts are targeted and infected with malicious software that can cause a variety of problems. If you imagine, the worst thing is called as ransomware. The best example being the WannaCry, which encrypts the data on a host and locks access to it until a ransom is paid. You will see a screen showing that all your data has been locked, so please pay so and so money in the form of Bitcoin only. Then you will be given a public key to decrypt your data. That is one of the variant of malware. There are many other ones, including spyware, adware. Different ways are there. As I said, one of the most troublesome thing is the ransomware. Now, what are the different network security devices that we come across in endpoint security? Earlier days, it used to be different, but now various network security devices are required to protect the network perimeter from outside access. These devices may include the following. The first one being the VPN-enabled router, that is a virtual private network-enabled router. This provides a secure connection to remote users across a public network and also into the enterprise network. The VPN services can be integrated into a firewall. The second variant is the NGFW, which stands for Next Generation Firewall. This provides stateful packet inspection, application visibility and control, a next generation intrusion prevention system NGIPS, and advanced malware protection AMP and URL filtering. The third one being the network access control NAC. This includes authentication, authorization, and accounting services, commonly termed as AAA services. In large enterprises, these services can be incorporated into an appliance that can manage access policies across a wide variety of users and device types. One of the examples for that is a Cisco's Identity Services Engine, ISE, which can be quoted as an example for the NAC device. Now, if you talk about endpoint protection, as I told you earlier, endpoints are nothing but the hosts which commonly consist of laptops, desktops, servers, and IP phones, as well as employee-owned devices. Endpoints are particularly susceptible to malware-related attacks that originate through email or web browsing, because we commonly access internet or access email through our endpoint devices only. Traditionally speaking, these endpoints use host-based security features such as antivirus, anti-malware, host-based firewalls, and host-based HAPS, host-based intrusion prevention systems. But nowadays, endpoints are best protected by a combination of NAC, network access control, advanced malware protection software, AMP, and ESA, email security appliance, and also a web security appliance, WSA. Let us see what these are. So, the first one being the Cisco's email security appliance, commonly called as ESA. This is a device that is designed to monitor the simple mail transfer protocol, SMTP. This device is constantly updated by real-time feeds from a Cisco Talos, which detects and correlates threats and solutions by using a worldwide database monitoring system. The threat intelligence data is pulled by the ESA every 3 to 5 minutes, so it constantly updates itself. What are the basic functions of a Cisco ESA? It can block known threats. It can remediate against stealth malware that evaded initial detection. It can discard emails with bad links. It can also block access to newly infected sites, encrypt content in outgoing email to prevent a data loss. Now, if you see in this diagram, you can see there is an ESA situated here. There is an ESA situated here. I'll show you. There you go. There is an ESA situated here, and this is the attacker. Now, if a threat actor, what will happen is he sends a phishing attack to an important host on the network. Let us assume that this is one of the important hosts, maybe a higher level executive working on it. Now, the firewall forwards all email that is incoming to the ESA first. So the first step, the attacker sends an email. In the second step, the firewall sends that to the ESA. Then the ESA will analyze that email, will go through the contents, will check it. And if it finds to be maybe a malware, or it finds to be infected, then automatically it will discard it. It will not forward that email into the internal network. This is the job of a CSK. It will discard the emails with any bad links, or if it finds some kind of infection attached to it. This is the job of the ESA. Now, what about the WSA, the next one? Okay. So, Cisco's web security appliance is a mitigation technique for web-based threats. It helps organizations address the challenges of securing and controlling the web traffic. Now, the Cisco's WSA combines advanced malware protection, application visibility and control, acceptable use policies controls, and reporting. It also provides complete control over how users access the internet. Now, if you are a network administrator and you want to make sure that you impose some restrictions on the usage of the internet, which websites that you allow or which websites you want to block, all those things can be done through the WSA. So certain features and applications such as chat, messaging, video and audio can be allowed, restricted with the time and bandwidth limits, or blocked according to the organization's requirements. So everything can be controlled. The WSA can perform blacklisting of URLs, URL filtering, malware scanning, URL categorization, web application filtering, and encryption and decryption of web traffic. So once again, if you check out in this particular diagram, if there is maybe let us say a fraud website, or if a user is trying to attempt or connect to that particular website using his mobile phone, all that particular things are then forwarded to the WSA. Then the WSA evaluates the URL entered by the user, and it determines whether it is a known blacklisted site or not. It can also do other things. As I told you, it has got many features attached to it. Then if it finds to be, if it's not a blacklisted site and if it is an allowed website, then it will automatically forward that request to the internet. But if that URL is in the blacklist, then it will automatically discards the packet and it will send a message to the user back saying that your access is denied. You cannot access this particular web page now. So an internal corporate employee uses a smartphone to attempt to connect to a known blacklisted site. It will not be able to do so because of the WSA. So this is regarding your ESA and WSA. Now let's talk about access control. What do you mean by access control? Why do you need to implement it? The name itself tells you access control is nothing but how do you control the access of the resources by the users. There are many ways of doing it. So there are some simpler ways as well. Let us talk about if you want to implement access control on networking device, there are many types of authentication that are available. The simplest method is of remote access authentication is to configure a login and password. We have been doing this in our initial configuration steps of switch and router from module 1, line with device 0 to 4, password Cisco login. Then the other way of doing it is configure SSH. We studied SSH in the first module also. So it requires a username and password. It goes through the local database, and it also encrypts all the traffic that comes and goes through SSH. But using such a local database has got two primary limitations. The first limitation is user account must be configured locally on each device, which is not scalable. It's not possible to write down all the accounts, usernames and passwords onto a single device on each and every device. It's not scalable. Second thing is there is no fallback authentication method. If this fails, there is no other way to get around it. So the entire system goes to failure. There is the next one, something called as AAA. So AAA stands for authentication, authorization, and accounting. This provides the primary framework to set up access control on a network device. AAA is a way to control who is permitted to access a network via authentication, what they do while they are there, authorization, and to audit what actions they perform while accessing the network. In simple terms, is the individual permitted to access the network or not? First, you need to authenticate him. Okay, if he is permitted to access, then send him in. And once he is inside the network, whether he is doing the actions that he is permitted or not, he is doing the actions that is permitted or not, that is authorization. And then whatever he does, you account them or you log them in. That comes under accounting. If you just check out your credit card, now you have your own name and the other details on the credit card. That comes under authentication. Who are you? And how much you can spend is the authorization. What is your maximum credit limit? And then how did you spend your transactions? How much did you pay for something? Everything. All of those things comes under your accounting part. So these three: authentication, authorization, and accounting. These are called as the AAA component for access control. Okay. So first, let us start with authentication. As I just told you, there are two ways of doing it. One of it is the local AAA authentication. The other one is the server-based AAA authentication. In local-based authentication, what happens is all the usernames or passwords are locally stored on a network device. Usually it's the router. And users, when they try to enter in, they submit their username password to the local database. And if the username and password match what it is inside, they get access. This method is easy to implement, but it only suits for smaller networks where there are few number of users. If you go for a large enterprise network, the other method, which is the server-based AAA authentication, is far more suitable. Here, in this particular method, the router accesses central AAA server. There is a central AAA server which holds all the details. The AAA server contains the usernames and passwords for all users in the network. Every user's username and password is stored there. The router then either uses the RADIUS, Remote Authentication Dial-in User Service. That's what it stands for, RADIUS, or RADIUS, or TACACS Plus, which stands for Terminal Access Controller Access Control System. These are the protocols to communicate with the AAA server. When there are multiple routers and switches, server-based AAA is more appropriate. As I said, for large enterprise networks where you have large number of users and more number of network devices, this is the best method, or this is the best approach. Now, if you see here, this is the first approach that I just explained, which is your local AAA authentication, where everything is stored on the network or on the network device, just like a router. And whenever the client wants to access the internet, he or she will provide the credentials to the router. And upon providing the credentials, the router will check whether it matches the entry that is stored inside or not. And if it matches, it will automatically provide access. This is the local AAA authentication. As I said, there is always a limit to the number of entries that a router can hold. Whereas coming to the second option, which is called as a server-based AAA authentication, we have a AAA router and also a AAA server. All the details for each and every user is stored on the AAA server. So whenever a client is trying to access the network, to whichever network device he or she is connected to, that device will forward the credentials to the AAA server, and based on the credentials submitted by the router, the AAA server authenticates the user and password name, and then if they match, it will say yes or no. That means provide access or reject access. This is the way through which server-based AAA authentication is handled. So here there is no server, here there is a server. And this method is best suited for large networks, which contain more users and also large number of network devices. Now let's talk about authorization. As I told you, authorization is automatic and it does not require users to perform additional steps after authentication. Authorization governs what users can and cannot do on the network once they are authenticated. That means you gave your credentials, you are a valid user, and you entered into the network. Now, what do you do in the network? What type of actions you perform? Whether these actions are permitted by you or not, all those comes under the authorization. So this uses a set of attributes that describes the user's access to the network. These attributes are used by the AAA server to determine privileges and restrictions for that particular user. If there is one user, we will check out the attributes and whether the action that he is trying to perform is allowed or denied. If it is allowed, fine. If it is denied, you simply cannot allow the user to do that particular task. This comes under authorization. And the third A, which stands for accounting. So AAA accounting collects and reports usage data. This data can be used for such process such as auditing or billing. The collected data might include the start and stop connection times, executed commands, number of packets, number of bytes. So literally whatever tasks a user is doing on the network once he's in, all the things that he has done will be logged up. The primary use is it keeps a detailed log of exactly what the authenticated user does on the device. This includes all the executing and configuration commands issued by the user. It also contains other fields including the username, date, time, which file has been accessed, at what time it has been accessed, what type of access has been made. This serves as kind of evidence when individuals perform malicious acts. This comes under logging, or in other terms we call it as accounting. So these are the AAAs: authentication, authorization, and accounting. This is how access control is maintained. The other way of doing it is through the 802.1x. This is a standard of IEEE, which is a port-based access control and authentication protocol. This protocol restricts unauthorized workstations from connecting to a LAN through publicly accessible switch ports. We talked about switch ports earlier. The authentication server authenticates each workstation that is connected to a switch port before making available any services offered by the switch or the LAN. So whatever device is being connected to whichever switch port, we have to first verify them. And after authenticating those devices only, the switch can provide the services. Now, if you see in this diagram over here, you can see that there is a supplicant. There are three actors: authenticator and then authentication. The supplicant is nothing but the client device. So the client device is the one which requires access and responds to requests from switch. This is the supplicant or the client. The second one or the third one is the switch, the middle one, which is also called as the authenticator. This acts as an intermediary between the client and the authentication server. The switch requests the identifying information from the client. It verifies the information with the server and then relays a response to the client. If there is no switch, the other device which is a very good candidate for authenticator is your wireless access point, AP. The third one is your authentication server. This is the one which actually stores all the identities and it performs the client authentication. The server validates the identity of the client and notifies the switch or the wireless access point whether that client is authorized or not to access the LAN and switch services. So this decides whether this client can be provided access or not. Now, this is how 802.1x standard works. So let us now move on to the layer 2 security threats. How many of you still remember the OSI model, the 7 layers of the OSI model? So this is what we spoke about the layer 2. As I said, layer 1 is the physical layer. Layer 2 is the data link layer. Layer 3 is the network layer. Layer 4 is the transport layer. And layer 5 is the presentation layer, and then, session layer, and then comes the presentation layer. Layer 7 is the application layer. What happens is, generally, network administrators routinely implement security solutions to protect the elements in layer 3 up to layer 7. They use VPNs, firewalls, and IPS devices to protect these elements. But what happens if layer 2 is compromised, which sits at the bottom? If a threat actor gains access through layer 2 frames into the network, then all the remaining layers would be easily compromised. So the threat actor could cause a lot of damage on the layer 2 LAN networking infrastructure. So what we need to do is we need to see to that we have to safeguard your LAN, your layer 2 security as well. So let's talk about that. What are the different threats that happen? First comes the switch attack categories. Security is only as strong as the weakest link in the system, and layer 2 is considered to be that weak link. This is because the LANs were traditionally under the administrative control of a single organization. All the internal people are trusted, and also the devices connected to our LAN. Today, the problem is everybody with the BOID, that is bring your own device, happening across, and more sophisticated attacks. Our LANs have become more vulnerable to penetration. So these are the different categories of attacks that usually takes place. The first one is the MAC table attacks, which includes the MAC address flooding attacks. Next one is the VLAN attacks, which includes VLAN hopping and VLAN double tagging attacks. It also includes attacks between devices on a common VLAN. The third category is called as the DHCP attacks, which include DHCP starvation and DHCP spoofing attacks. ARP attacks. This includes the ARP spoofing and also the ARP poisoning attacks. Address spoofing attacks, which includes MAC address spoofing and also IP address spoofing. We also have the STP attacks, which includes the spanning tree protocol manipulation attacks. We'll discuss about each one of these attacks in detail, how the threat actor can perform these attacks and what will be the impact of these attacks. Before doing that, we need to find out how do you mitigate them? What is the solution? Now, for the MAC address flooding attacks and the DHCP starvation attacks, you can implement port security. DHCP snooping can be implemented to prevent DHCP starvation and also DHCP spoofing attacks. The other one is called as dynamic ARP inspection, DAI, which can prevent the ARP spoofing and the ARP poisoning attacks. IP source guard, IPSG, prevents MAC and IP address spoofing attacks. There are some other layer 2 solutions. If not, they are not actually good enough if not proper protocols are maintained. The following are some of the strategies which can be implemented to safeguard all of these solutions. Always use secure variants of management protocols such as SSH, secure copy protocol, secure FTP, and SSL/TLS, secure socket layer for transport layer security. Consider using out-of-band management network to manage the devices. Use a dedicated management VLAN where nothing but management traffic resides. Use ACLs, access control lists, to filter unwanted access. So these are some of the strategies that are recommended to make sure, in addition to all these solutions that we said, to make sure that you can mitigate some of the layer 2 security threats. Now, what do you mean by a MAC address table attack? How can an attacker perform this? If you can see, all MAC tables have a fixed size, and consequently a switch can run out of resources in which to store MAC addresses, because a switch does not have an infinite buffer space. It will have some fixed amount of space. The MAC address flooding attacks take advantage of this particular limitation by bombarding the switch with fake source MAC addresses until the switch MAC address table is full. There is no more space to add any more entries. When this occurs, the switch treats the frame as an unknown unicast and it begins to flood all incoming traffic out on all the ports. Now, how is this beneficial to an attacker? If you see, this is the attacker, and what he does is he sends these MAC of attack, and he sends numerous number of frames to the switch. So ultimately, by the time this switch MAC address table is full, what it does is it starts forwarding traffic and out on all ports. Now, how this fellow can be benefited is, earlier the switch only used to forward the traffic into the VLAN 10, but now because it is now unable to go and access the MAC table because it's full, it starts bombarding traffic and out on all ports. The threat actor is now in a position to receive the traffic, to capture the traffic that is actually entitled for VLAN 10. This condition now allows a threat actor to capture all of the frames sent from one host to another on the local LAN or even the local VLAN. Because usually when you talk about switch forwarding the traffic, it only forwards the traffic on a particular port based on the MAC table. But if the MAC table is full, the switch doesn't know what to do, then it has nowhere to go. It simply keeps sending out traffic on all the outgoing ports. Now, why we need to bother? The problem is these tools such as MAC-off are so dangerous because the attack which I just told you, the attacker can do it in a matter of seconds. Consider this as an example. A Catalyst 6500 switch can store up to 132,000 MAC addresses in its MAC address table. A tool such as MAC-off can flood a switch with up to 8,000 bogus frames per second, creating a MAC address table overflow attack in a matter of few seconds. So it is very easy and it's very fast. The another reason is this just does not affect that particular switch itself. When you have a network, one switch is connected to other switch, and if a switch starts forwarding traffic on all the outgoing ports, automatically this will impact the other layer 2 switches also, because the other switches now receive all this unwanted traffic. So to mitigate the MAC address table overflow attack, network administrators must implement port security. So port security will only allow a specified number of source MAC addresses to be learned on the port. We'll study about port security, how to implement it on a switch in our next module, module 11. But port security plays a key role, and it is a must skill for a network administrator to safeguard. Now let's talk about the LAN attacks. What are the different types of LAN attacks, right? So the first thing we are going to talk about are the VLAN hopping attacks. A VLAN hopping attack enables traffic from one VLAN to be seen by another VLAN without the aid of a router. So in a basic VLAN hopping attack, the threat actor, what he does is it configures a host to act like a switch, to take advantage of the automatic trunking port feature enabled by default on most of the switch ports. We have studied VLANs in our module 3 and module 4. We studied about the trunk ports too. Now the threat actor configures the host to spoof the 802.1q signaling and the DTP signaling to trunk with the connecting switch. If he is successful, the switch establishes a trunk link with the host. You can see here, this is an unauthorized trunk. This attacker has gained access to the switch by getting hold of by making use of this automatic trunking port feature. Okay, the threat actor can now send and receive any traffic on any VLAN, effectively hopping between VLANs, because now he's having a trunk port directly to the switch. He gains access to the server. He gains access to the VLAN, any VLAN he wants. That is the reason this attack is called as a VLAN hopping attack, because the threat actor can send and receive between different VLANs, not just only one VLAN. Now, this is a double tagging attack. Double tagging attack. The name itself is self-explanatory. Here, what the threat actor does is he can embed a hidden 802.1q tag inside the frame that already has a 802.1q tag. I told you about tags which allow the switches to redirect the traffic into the appropriate VLANs we use. And also I told about the native VLAN, which actually allows the traffic from all the things to go through. That is what we call as a native VLAN. Now the threat actor sends a double tagged 802.1q frame to the switch. The outer header, this is the one, VLAN 10, has the VLAN tag of the threat actor, which is the same as the native VLAN of the trunk port. This is the trunk, this matches the native VLAN. So when the switches see this, they don't bother. So then the frame is destined for the native VLAN. The switch simply forwards the packet out on all native VLAN ports after stripping the VLAN tag. The frame is not retagged because it's part of the native VLAN. At this point, the inside tag is still intact. The outer tag is only stripped. The inner VLAN tag is still intact and has not been inspected by the first switch. So which leads to step 3. The frame arrives at the second switch, which has no knowledge that it was supposed to be for the native VLAN. because of inside of this particular tag, you can see here the second switch looks at only the inner tag, and the threat actor inserted and sees that the frame is destined for the target VLAN. So this frame is now forwarded into the VLAN 20. So once the threat actor can start sending traffic into the VLAN, he can do any number of things. He can flood it, he can add something to it, he can do whatever he wants to. So this is called as a double-tassing attack. So it is unidirectional and works only when the attacker is connected to a port residing in the same VLAN as the native VLAN of the trunk port. As I told you, the first tag should match the native VLAN. The idea is that the double tagging allows the attacker to send data to hosts or servers on a VLAN that otherwise would be blocked. So usually the attacker should not have access to the particular VLAN, but because of using this, he now has, in the earlier picture we shown you, the attacker can be able to send the data to VLAN 20, which otherwise would not have been possible. So how do you stop this? So VLAN hopping and VLAN double tagging attacks can be prevented by implementing the following trunk security guidelines. This is also we discussed in the previous module when we are working with trunks. Disable trunking on all access ports. Disable auto trunking on trunk links so that the trunks must be manually enabled, and be sure that the native VLAN is only used for trunk links. Just don't leave all of them open. So this is how you mitigate the VLAN attacks, which includes the VLAN hopping and the VLAN double tagging attacks. Next comes DHCP. We studied DHCP in the earlier module. You know about the procedure, how DHCP works, DORA. Okay. So the goal of this attack, the first kind of attack which can be happening is DHCP starvation attack. This is to create a denial of service attack for connecting clients. So if a client wants to have an IP address with DHCP starvation attack, he will not get it from the DHCP server, because these attacks use a tool such as Gobbler. So Gobbler has the ability to look at the entire scope of the leasable IP addresses and tries to lease them all. If there are no addresses to provide, the DHCP server is in no position to provide an IP address to the client. So it creates DHCP. This Gobbler, what it does is it creates the DHCP discovery messages with bogus MAC addresses. The second type of attack is something called as a DHCP spoofing attack. So this occurs when a rogue DHCP server, imagine that a DHCP server which is under the control of an attacker, is connected to the network, and it starts providing you the false IP configuration parameters. When automatically when you switch on, your device is dependent on the parameters that it received from the DHCP server to configure its IP address and other parameters to connect to the network. But what if the server itself is compromised? It can receive different types of misleading information, including the wrong default gateway. It can also receive a wrong DNS server, thereby directing your request to a nefarious website. The third one is a wrong IP address. It can provide an invalid IP address so that the client will never be able to connect to the internet. So these are the things that can happen. So DHCP starvation attack and DHCP spoofing attack. The next category of attacks falls under the ARP category. Now you know the address resolution protocol, which provides you to the MAC address for a given IP address. All hosts on the subnet receive and process the ARP request. Usually ARP requests are broadcasts, and the host with the matching IP address in the ARP request will provide the ARP reply back, so that the sender will now know the MAC address, and he will link that MAC address with the IP address. A client can send an unsolicited ARP reply called as a gratuitous ARP. Other hosts on the subnet store the MAC address and IP address contained in this ARP in their ARP tables. A threat attacker can use this loophole. If an attacker can send such a gratuitous ARP containing a spoof MAC address to a switch, and automatically the switch will update its MAC table accordingly. In a typical attack, the attacker can send unsolicited ARP replies to other hosts also on the subnet with the MAC address of the threat actor and the IP address of the default gateway, effectively setting up a man-in-the-middle attack. By spoofing in such a way that the attacker can place himself in the middle of the network, so that all the traffic that comes and goes through the network or the communication happening between the hosts will pass through him, which is also called as a man-in-the-middle attack. There are many tools available on the internet to create such an attacks. IPv6 uses the ICMPv6 neighbor discovery protocol for the address resolution. It does not use ARP. IPv6 includes strategies to mitigate neighbor advertisement spoofing, similar to the way IPv6 prevents a spoofed ARP reply. ARP spoofing and ARP poisoning are mitigated by implementing the dynamic ARP inspection, also called as DAI. IPv6 is far better in security compared to IPv4 with usage of the ARP protocol. Now let us talk about the address spoofing attacks. What do you mean by address spoofing? As I told you, there are many ways of doing it. The first one being the IP address spoofing is when a threat actor hijacks a valid IP address of another device on the subnet or uses random IP addresses. IP address spoofing is difficult to mitigate, especially when the spoofed address is belonging to the same subnet. It becomes very tough to detect it. MAC address spoofing attacks occur when the threat actors alter the MAC addresses of their host to match another known MAC address of a target host. What it will do? The switch will automatically write over the MAC table and can start sending the information to the attacker rather than the real host. When the target host sends traffic, the switch will correct the error, realigning the MAC address table to the original port. But attackers are quite clever. So to stop the switch from returning the port assignments to its correct state, what they can do is the threat actor can create a program or script that will continuously send frames to the switch so that the switch maintains the incorrect or the spoof information. The problem is there is no security mechanism at layer 2 which allows a switch to verify the source of the MAC address, whether it is genuine or not, whether it is actually receiving a spoofed MAC address from somebody else. So the switch is very much vulnerable to spoofing. IP and MAC address spoofing can be mitigated by implementing a technique called as IP source card, IPSG. Then comes the STP attack. We studied STP in this module itself. I told you how spanning tree gets rid of the redundant paths. So, and we also talked about the STP BPDUs, bridge protocol data units. Attacker can use these BPDUs and can strategically send the BPDUs, which will force the spanning tree recalculations. If you remember, the switch with the lowest bridge priority will become the root bridge. The attacker can send spoofed BPDUs in such a way with its switch having the lowest priority and automatically forcing the spanning tree recalculation and making its designated switch as the root bridge. This type of STP attack is mitigated by implementing BPDU guard on all access ports. This we actually practiced implementing BPDU guard also. We will be studying it again in module 11, where we study about switch security. The last thing is your CDP protocol, which stands for Content Discovery Protocol. This is from Cisco. It is enabled on all Cisco devices by default. Why it is used? It is actually used by the network administrators to help configure and troubleshoot network devices. This CDP information is sent out on all CDP enabled ports in periodic, unencrypted, unauthenticated broadcasts. So CDP information includes what type of information does it have? It includes the IP addresses of the device, the software version, the capabilities, the platform, and also the native VLAN. The device which receives the CDP message will update its CDP database. So once CDP is such a prime source of information, automatically it is prone to attacks. To mitigate the exploitation of CDP, limit the use of CDP on devices or ports. For example, what you need to do is you need to disable CDP on edge ports that connect to untrusted devices. So if you know that the port is open, which you might be connecting it to some edge device which you are not happy about, then you simply disable it. So disable CDP globally on a device, you need to type in the command no CDP run. To do the same on a particular globally, if you want to enable it, you simply do it the CDP run. If you want to disable it, just type in no CDP run. If you want to disable CDP on a particular port, you can simply type in no CDP enable in the interface configuration. And if you want to bring it back up, you can simply type in CDP enable. There is another protocol, link layer discovery protocol, called as LLDP. This is also vulnerable to reconnaissance attacks. So what we need to do is we can configure simply no LLDP run to disable LLDP globally. If you want to just do it on interface, what we can do is we can do the no LLDP transmit and no LLDP receive. So these are all the different types of attacks that happen on local area networks, LANs, VLAN hopping. So in this particular module, we concentrate more on the types of attacks, what type of impact it creates, and how they can be carried out. In the next module, which is module 11, we study about switch security, port security, how to mitigate these attacks. What are the different commands that we need to use in order to implement port security? So all those things we will be covering in module 11. So hopefully you understood this particular video. Thank you all for watching this.